Welcome back, guys. Today I'm really excited to start our unit on trigonometry. This is one of my favorite units in math. Today we're going to be looking at a two-part video. So I've divided our lesson into two parts. In the first video, we're going to be looking at a review of Pythagorean theorem. We're going to look at some conventions, some naming conventions for triangles, and then we're going to start getting into the labeling of triangles, and that labeling is sort of our key starting point for trigonometry. In the second video, we're going to get into the actual trig ratios and the solving of right triangles. Now, before we get into the naming conventions, it's important that we take a real quick look at the word trigonometry. If we watch different movies or TV, especially teen dramas, trig kind of gets a bad rap as being the tough math. Now, certainly there's different components to trig, and we're just starting off with the basics in grade 10, but ultimately, trigonometry can be broken down into three words. So tri stands for three, just like tricycle has three wheels. Trigonometry has three. Gon stands for sided, so three-sided. Polygon is multi-sided. Trigon is three-sided. And metry stands for measure. So trigonometry is really just three-sided measure. In other words, we're going to be looking at objects that have three-sided measures, meaning this entire unit is all about triangles. All right, so let's start off with looking at sort of the language of trig and some review from things you would have done in junior high. Now, in this unit or in this course, we're going to be working with right triangles only. Trigonometry doesn't just stop at right triangles, but that's where we're going to be starting for grade 10. Now, a right triangle is a triangle that contains a right angle. So in Math 10, we look at right triangle problems. In Math 20, we're going to look at triangle problems that involve both right triangles and non-right triangles. And then in Math 20 and then leading into Math 30, we also start to look at trig functions, and we'll look at the entire circle, so entire 360 degrees. In Math 30, then we go much further with that. In 30-1, we start getting into trig functions and trig identities. In Math 30-2, we look at sinusoidal functions, and we do that as well in 30-1. All right, so when we're naming our triangles, we name our triangles using vertices. And vertices are usually labeled with capital letters. So if I wanted to label this triangle, I would call it triangle ABC. I could also call it triangle CAB, but notice that everything's named based on the vertices. If I wanted to name this triangle, it would be triangle DEF. All right, so some other naming conventions, what you may have noticed already is that our vertices are all labeled with capital letters. When we want to label our sides, we're going to label our sides opposite our angles. So the side across from angle C is side C. Notice it's the same letter, but it's lowercase. Side B is across from angle B, and side A is across from angle A. If I wanted to label this triangle here, side F is opposite angle F. Side E, it's kind of a non-straight line there. Side E is opposite angle E, and side D is opposite angle D. Now, looking at angles, if I want to identify the specific angle that I'm looking at, the vertices of a triangle help us to name the angles of a triangle. So if we wanted to name the angle of this triangle here, I could call this angle A. I can call this angle B. Notice I'm going to put a double line there because these angles are not the same size. And then I have angle C. And so angle B would have my angle symbol, angle C, and angle A. Now, if I wanted to show that two angles were the same, for example, in an isosceles triangle, I would use the same line for both. If I wanted to show the sides were the same, I would show the same line for both. Now, when it comes to labeling angles where I have maybe multiple components and it's not clear what angle A, for example, means, then I need to give much more detail. So if I just wrote angle A here, that could mean this angle, it could mean this angle, or it could mean the entire angle. So it's important that we have some clarity. And so we do that by defining our angle using the vertices. So if I wanted to name this angle here, BAC, that means I'm going from point B 2 point A, 2 point C, and the angle contained between those points is my angle. If I was looking at angle ADC, going from point A to point D to point C, the angle contained in between would be angle ADC. If I wanted to have this angle right here, that would be angle BAC. So I'm going, BAD. I'm going to go from point B to point A to point D, and the angle contained between them would be angle BAD. All right, two other terms that we use quite a bit in trigonometry is angle of elevation and angle of depression. So if we're looking at angle of depression, this is the angle formed by the horizontal and a line of sight below the horizontal. So if I'm looking straight out here, my horizontal would be this line right here. And if I look down, if I depress my eyes, so if I'm feeling down, I might be feeling depressed. If I depress my eyes, I'm looking down. So if I were to depress my eyes and look down in this direction, the angle between my horizontal and where my line of sight is now is the angle of depression. In contrast to that, if I have the angle of elevation, that's the angle formed by the horizontal and a line of sight above the horizontal. So again, if I'm looking out horizontally, there would be my line of sight. If I elevate my eyes or I raise my eyes, the angle to which I raise my eyes is my angle of elevation. Now, something that's important to point out here is that angle of elevation and angle of depression are actually equal. So if you remember from junior high, if we were looking at parallel lines and we were looking at a transversal, so the transversal would have been here. Maybe color that with a different color. I would have an alternating angle and my angles here would be equal. Well, when I'm looking at angle of elevation, angle of depression, these are the same angles. Now this is going to come in handy when we're drawing a diagram. For example, I might be drawing a picture of a balloon being up in the air, and I'm told my angle of elevation. My angle of elevation would be here. My angle of depression would be the same thing here, and that might help me to draw my diagram. Okay, so again, angle of elevation equals angle of depression. Angle of depression looking down from the horizontal, angle of elevation looking up from the horizontal. Now, one other application that we can use for trigonometry is physics. In physics, you're going to look at something called vectors, and so you'll start off with the right triangle trigonometry, and then you'll eventually get into non-right triangles. So this has a direct relationship with physics. All right, so some other things that we need to remember. The sum of the angles in a triangle is 180 degrees. So if I were to add up all of the angles in a triangle, they should total up to 180. That will come in handy if we're trying to find missing angles and we know two of the angles already. The other thing that we use quite a bit is the Pythagorean theorem. Now, if you remember that from junior high, the sum of the squares of the shorter sides equals the square of the hypotenuse. So we have a squared plus b squared equals c squared. Now we're still going to use this formula a lot in high school, but I am going to show you a little bit of a shortcut that we can use as well. All right, so let's get into some review of Pythagorean theorem. So we have this triangle here. We're told that the short sides are 5 and 12, and our long side is x. Well, using our Pythagorean theorem, again, the formula is a squared plus b squared equals c squared. And so if I wanted to set up my formula the way that I likely would have done it in junior high, I would be writing 5 squared plus 12 squared equals x squared. And then simplifying, that gives me 25 plus 144 equals x squared. 25 and 144 is 169 equals x squared. And then my next step would be to square root. And I have 13 equals x. In other words, x equals 13 centimeters. And so this is completely valid to do. This is how you would have learned to do it in junior high. I'm going to show you a little bit of a shortcut. Whenever I've taught trig, I find when it comes to Pythagorean theorem, one of the most common mistakes is for students to forget to square root at the end. And so they write their answer as 169 instead of 13. And so if we have the equation a squared plus b squared equals c squared, we can manipulate the equation before we get started. If I want to have c by itself, I just have to square root both sides. So that would tell me that the square root of a squared plus b squared equals c. And by putting that square root in right away, we're less likely to forget it when we're putting it into our calculators. So these are both valid methods. You can do whichever one you prefer, but you will often see me use sort of the manipulated version to begin with. I call it a shortcut, but really it's just manipulating the equation before I plug in my values. So if I wanted to write that out using this method here, I have two short sides, so that means I'm adding. So the square root of 5 squared plus 12 squared equals x. Now, once I've done it like this, I can actually go straight to my calculator and type in my information. So second root 5 squared plus 12 squared, enter, gives me 13. So once I have it written out, I can answer it. I can do it in my calculator in one step. So x equals 13 centimeters. Now, when we're doing this shortcut method, so to speak, it's important that you remember that when we have the long side and a short side, then we have to subtract. So I'll again write this out the way we would have done it in junior high. We would have had 20 squared, sorry, let me try that again, 29 squared. Actually, I'm going to try this one more time here. The way you would have likely written it out is this way. You would have probably written 20 squared plus x squared equals 29 squared. And your 20 squared would have been 400, and your 29 squared would have been 841. So you would have had 400 plus x squared equals 841. You would have subtracted 841 minus 400 to get 441. And then you would have had to remember to square root. So likely that's how you did it in junior high. You might have manipulated it to begin with as well. So second root 441 gives us 21. So you would have had x equaling 21 centimeters. Now, using the other method, remembering if I have hypotenuse and a short side, I'm going to be subtracting. I would write it this way. X equals 29 squared minus 20 squared. And again, doing that on my calculator, I'm going to have 29, so second root 29 squared minus 20 squared gives me 21. All right, so I'd have x equals 21 centimeters. All right, so let's take a look at these last two here. You might want to pause the video and try them on your own first. I'm going to do both of these using that so-called shortcut method, which again isn't really a shortcut. I've just manipulated the equation ahead of time. So for this first question here, I've got a 4 and a 3. These are two short sides. That means I'm adding. So I'm going to be writing the square root, x equals the square root of 4 squared plus 3 squared. Now you can simplify that down if you want. 16 plus 9, and then x equals root 25, x equals 5. You could in your calculator just start with that first step. X equals the square root of 4 squared plus 3 squared and go straight to your answer. So x equals 5 centimeters. Now for our last question here, x equals the square root of 25 squared minus 7 squared. Again, you could write it all out if you choose to, or you can go straight to your calculator. The square root of 25 squared minus 7 squared is 24. Now they won't always be nice decimals, but to start off with here, I've kept them all as numbers that have nice decimal answers. All right, so now we're going to start getting into some of the other language of trig that we use quite frequently. When you look at how trig can be taught, some textbooks will teach you each individual ratio. I'm not going to do that. I'm going to start off with how to label a triangle, and once we label a triangle, then we have the opportunity to do all of our trig ratios together at once. Labeling our triangle is one of the most important starting points for trigonometry, and so understanding how to label those sides is really important. All of our sides are labeled based on our angles, and so the sides of triangles also have different names based on the angle. Now, hypotenuse is the one you're probably most familiar with. That's the side opposite the right angle, and it's always the longest side. Now, opposite is the side opposite the angle that we're working with. And then adjacent is the angle beside. So adjacent in English means beside. Now, often when we're working with opposite and adjacent, these get mixed up. And so I'm going to show you some tricks that we can use. So if my angle is right here, looking across the triangle, this would be called opposite. And I would have my 90 degrees here. Looking across from 90 degrees, this would be hypotenuse. So across from 90 degrees is always hypotenuse. And then if I have opposite and hypotenuse, this last angle here this last side here is adjacent. And notice that this is the side that's beside my angle. If I change where my angle is, then I change my labeling. So if my angle is down in the bottom right here, looking across is opposite. But if I move where my angle is, this side is no longer opposite, it's actually adjacent. So I'm going to put in my 90 degrees again. 90 degrees is often the easiest one to label as hypotenuse. And looking across from the triangle is opposite. So opposite is always across the triangle. And that leaves adjacent is beside. Now in school, I often mixed up opposite and adjacent, but once I got in the habit of labeling my opposite and my hypotenuse, then I knew the leftovers were adjacent. So whatever strategies you can use to help remember these, that's important. So opposite or hypotenuse is across from or opposite 90 degrees. Opposite is across from the angle, and adjacent is beside the angle. So again, looking here at this diagram here, we've got a little play on words there. We've got hypotenuse. If my angle X is here, across from the triangle is opposite, and notice angle A is side A. Looking across from 90 degrees here, we have hypotenuse or hypotenuse, and then beside the angle would be adjacent. Now notice that little b is opposite of capital B. So if I was wanting to label my sides here, opposite would be side A, adjacent would be side B, and hypotenuse would be side C. Now it's that labeling that's the important part to starting with trigonometry. So we're going to look here at how we actually label our triangles. And so this might be a time when you want to pause the video, set up these triangles, or at least think about how you would label them, because again, this is our first step in trig. So if my angle is here, looking across the triangle, this would be opposite. Often I'll just use 3 letters. Across from 90 degrees is hypotenuse, and that makes this adjacent. If I look at my angle here, this side here would be hypotenuse, this side here would be adjacent, and this would be opposite. Again, if it helps, draw in your triangles. So opposite is across from the angle, hypotenuse, and adjacent. And our last one here, this side is adjacent. We have opposite, and we have hypotenuse. So across from 90 is hypotenuse, across from the angle is opposite. All right, so that's the end of our naming videos here. In part 2, we're going to actually do a quick review of this naming piece, and then we're going to get straight into trig ratios and how we use them to solve triangles. All right, we'll see you in part 2.